Hey, my name is Lukas and today I want to give you a step-by-step guide how you can set up TLS for Postgres in Docker. So let's get started. I already created this example project right here in GitHub. So let's quickly grab the code from here. In your case, you have to create a fork of this repository first before you can download all of the files. I'm in my code editor right now. And as you can see, there are basically 4 files in this repository: the README, then there's a Docker file, an entry point, and an SSL config.sh. If we take a look at the Docker file, we are starting from Postgres, from the official Postgres image as our base image. Then we will copy the SSL config into the Docker entry point directory. And everything that ends up in this directory will get executed on first startup. And next step, we will copy the entry point script to our image. We will make it executable, and then we will override the default entry point with the script that we just added to our image. So let's take a quick look on what these scripts are doing right here. So first of all, the SSL-config script. And it's basically only applying a few configuration settings that are necessary in order to run Postgres with SSL. We will turn on SSL, and then we will point to 3 certificate files that don't exist yet, but that we will create in a minute. And we will write this information to the PostgreSQL config. And as a last step, we will enforce all connections to be secure using this little line right here. And as you can see, we are using the SSL mode verify full, which is the strictest possible setting that you can use in order to secure your Postgres connections. So if we take a quick look at Postgres SSL mode, in the documentation, I will scroll down a little bit, and right here you have this description of what different SSL modes are doing. So on the one end of the spectrum, there is disabled, which is I don't care about security, I don't want to pay the overhead of encryption, which is very useful for development purposes, for example. But if you want to use Postgres in a more production setting, you might want to consider the other end of the spectrum, verify full, which is the most strict setting that is possible here, and it's basically protects against eavesdropping and man-in-the-middle attacks. And this is, I want my data encrypted and I accept the overhead. And this is what we will use right here. Okay, let's quickly take a look at the entry point as well. The entry point basically copies 3 different certificates to our Docker image. Then it will update the file permissions on these certificates, and then it will run the default entry point that we are overriding right here after we copied all of these certificates. As you can see, the script will only run if these certificates are present as environment variables. So we need to pass it to our Docker container as environment variables. All right, let's quickly go back to the repository, and as you can see, there is a link to a blog post which describes in detail of how we are going to use this repository. So if we scroll down a little bit, you can see it starts with generating certificates, and that's exactly what we're going to do. I will copy this first script section over here, paste it in my terminal, run it. As you can see, we have 2 new files, the rootca.crt and rootca.key. And this is going to be our local certificate authority that we will use in order to sign the other certificates that we are going to be creating. And if I scroll down a little bit, you can see this section, which will be used to create the certificates that are used server-side. And if we scroll a little bit further, there is the script which can be used to create certificates for the client. And if we take a closer look at all of these commands that we just executed, you can see there are a bunch of settings that you could customize. For example, you can change a different name for these keys right here. This one is called rootca.key or rootca.crt, but you can change the names right here. And as you can see as well, it is valid for 365 days from today. So this is something we need to keep in mind, that after 365 days, the certificate will be invalid again, and we need to renew it. So every connection that happens in 2 years, for example, if we don't swap out the certificate, it will not work because it will be invalid by that date. Another setting that is important right here is when we created the certificates on the server, there is this CN equals localhost, and this is the common name or domain name of our server. And for testing purposes, it is localhost right here. But if you're running Postgres on a different server, for example, in the cloud or another remote server, you need to make sure to add the domain name of this server right here. Otherwise, it won't work. All right, you can see a bunch of certificate files have been created right here. And one thing that is very important is that we treat these certificate files as secrets. And I will create a new file and name this one .gitignore. And right in here, I can add all of these certificate files that have been created. So you can see the certificate files, they are now grayed out, which means they are not checked into version control. Great. So let's hit save and let's continue with the little tutorial after we created the certificates. Next step, we will build our Docker image. So we already have this Docker file right here in our project. If we scroll down a little bit further, there are the instructions to build the image and to run it. So I will simply copy this command right here, paste it in the terminal. And now I get an error because my Docker daemon is not running. So we need to make sure to have Docker running right here. So let's quickly start up Docker. Docker is starting up. Let's quickly check with the docker ps command. We are not getting any errors, which means Docker is running. And let's run the build again. And this will probably take a few seconds. There we go, it already finished. And after we build our little Docker file or our little Docker image, we will spin up a container using this docker run command. And as you can see, the docker run command accepts 4 environment variables. We have the Postgres password, which is a arbitrary password that you can choose, and this one is set to secret, but of course you need to choose a very secure password if you want to use this in a production setting. Right here for demo purposes, it doesn't really matter. Then there is our server certificate, our server key, and our rootca.crt. And as you can see, there's a little script in here which simply grabs the content of these files right here and adds the content of these files to these environment variables. So if I hit enter, I can see another error message because I already have this container right here. The container is already somewhere in my Docker, so I will remove Postgres TLS first, and then I will run the command again. And as you can see, container is starting up and it is looking good. If we see that message, database system is ready to accept connections, it means we might have done something right. So let's quickly create a new terminal over here. And then we will check if we can connect to our database. And if we scroll down a little bit further right here, we have some commands to try if we can connect to our database. So I will paste this one in. As you can see, connection to server failed. Private key file client has group or world access. File must have permission 600. And this means we need to update the permission of these certificate files that we just created right here. because they're a little bit too permissive. So we will use the command called chmod, then we say 600 and we say client.key. So we just updated the permission of this client.key file and make it a little bit more restrictive. And this is required for this connection to work. As you can see, I just tried it again and I'm in the Postgres shell and I can run all of the Postgres commands that are available. So this is looking good. I will exit the shell right here and I will try something else. If we use, for example, a different SSL mode, and you can see SSL mode is disabled right here. If I hit enter, I will get an error. And this is expected because if you remember previously in our, not in the entry point, in the SSL config, we only allow verify full. And whenever somebody tries to connect to the database without using an encrypted connection, we will block him and not let him connect to the database. All right, great. So now we have the database running locally on our machine. So let me show you how you can move this to the cloud and run it on a cloud server, so you don't have to have your laptop running 24/7 in order to keep your database up. So let's get to sliplane.io. I will log in with my GitHub account and I will create a new project, call it Postgres TLS. I will click on the project, click on deploy service, and then I need to create a new server where my application will be running on. Location is default is Falkenstein, but you can choose any other location that you want. I will run with the default location and default server type right here, and I will give it a name and name it Postgres TLS, and I click on create paid server. After a few seconds, the server should be created and it shows up in the list. I will select the server. I will click deploy from repository right here, and in the repository drop down, I will look for Postgres TLS, and as you can see, it doesn't show up in the list because we first need to grant access to Sliplane to deploy this repository. So I will click on configure repository access, click on my GitHub account. Then I quickly need to sign in again. And if we scroll down a little bit, and I will look for Postgres TLS, there we go. Click on save. I'm redirected to Sliplane, and if I refresh the list right now, you can see the repository is showing up. So if we scroll down a little bit further, we need to change the protocol to TCP. It is a database. And then we need to provide some environment variables in order for this to work. And if you remember, if we go back to our terminal, I will, no, how do I get out of here? I don't remember. So let's just destroy the terminal. But if you remember right here, we have set 4 different environment variables, and we need to set these environment variables right now in Sliplane as well. So let's start with the Postgres password. I will make this a simple string secret. Then we need the server CRT environment variable. Copy it right here, and it is over here, server CRT. Copy it, paste it. Then next one was server key. Copy it, server key, select all, copy and paste. And the last one that we're going to need is this root CA underscore CRT. And let's also copy that right here and paste it in. So that's it for the environment variables. And the last thing that we need to configure is a volume, because we want to keep this data if we redeploy our application or if the server restarts. Since it is running in a container, it usually would be a complete new restart and everything would be gone. So we need to attach a volume right here. Name this one PG data, but you can name it whatever you want. And the mount path will be exactly this path that we are using right here also. It is var lib PostgreSQL / data, and we will tell Postgres, or we will tell Docker actually, keep everything that is inside this directory persistent, even if you redeploy. So let's click on deploy down here, and let's see if we made a mistake or if the deploy is going through. I will click on the service over here. As you can see, there are all of the settings that we just entered, and if I click on deploy in progress, I can see what is going on the server right now, and it is probably only going to take a minute or two, similar to when we started it on our local machine. And as you can see, it just switched to database is ready to accept connections. And if we go back to the settings, you can see the deploy is live, and we are hooked up with this public domain that we can use in order to access our service. So if you remember previously, I told you that the certificates that we created, they were for localhost only. So let's try what happens if we're trying to connect to this public domain right here. If we go back to the blog post and copy this little test script, paste it in our terminal, and then we will replace the host name. Instead of localhost, we are using this public domain right here. I will paste in the public domain, but without the port, and I will hit enter. And then you can see server certificate for localhost does not match name PostgreSQL.app. And this is something that we need to fix right now. So I go back into the blog post, scroll back up a little bit where we created the server certificates. Generate certificates, there we go. It's this little script section. I will copy that one again, go back into my terminal, and now instead of localhost as the common name, let me quickly remove that. Go back to Sliplane, copy the public domain again, and then I paste in this public domain name right here. Hit enter. As you can see, it has been generated, and we now need to grab this server key right here, copy it, go back to Sliplane, and swap out the server key, but also the server certificate. So check out the server certificate, copy it, and swap it out right here. I will click on save, and after hitting save, you can see a new deploy is in progress, and after a few seconds hopefully it will be live again, and we can try to connect to our remote instance again. Database system is ready to accept connections. The deploy went through. So let's get back to our terminal and try this little command that we executed before. Again, as you can see, we are now in the Postgres shell, and we can run whatever Postgres command we want. So that's basically it. That's all you need to know in order to spin up Postgres in Docker with encrypted traffic. I hope you liked this little tutorial. If you did like it, give it a thumbs up, comment, and subscribe, and I'll see you next time.